Hi, I'm Nick Ramsey. I am Professor of Cognitive Neuroscience at the University Medical Center of Utrecht. And I run a research team working on brain-computer interfaces in people who are completely paralyzed. The team in Utrecht is working on the next generation of BCIs, where we hope to be able to offer people who are paralyzed the ability to speak by trying to speak, and we translate it into speech on a computer. We'll start with trying to distinguish like 20, maybe 50 words, maybe 100 words. And the long term, we want people to be able to speak directly through a computer. It's very ambitious, and we don't quite know what kind of device we need for that, but we know that the next generation has to have 25 to 100 electrodes. The next generation that we're working on is one with many more channels, more amplifiers, so that we can get much better than a click. And our focus is on trying to decode speech, not thoughts, but speech. If you try to speak, even if you can't speak because your nerves are damaged, we can still pick up those activities in the brain and figure out what kind of word you're trying to speak. That's what we're doing research on now, in anticipation of a next generation implant, which has many more channels, somewhere between 25 and 100, so that we can get more sophisticated communication with the brain. So, I've been in this field for 15 years now. We have a device, we implant it with 4 channels, but it's no longer manufactured. So I had a lot of interaction with institutes and companies that are working on implantable recording devices. By now I know how hard it is to get something to the market. There are many, many achievements, many devices that are made, that are published on, that are not suitable for people. You can make a device, it can be state-of-the-art, extremely small and everything, but to use it in people, you have to prove that it's safe and that's reliable, and that's where 99% of the institutes and companies stop. They say, no, we're not going to do that, because that is a huge investment to prove to regulatory authorities that it's safe. You have to go through a lot of tests. You have to have other companies do the tests, and you have to build all the documentation. We call that regulatory. And that costs tens of millions, usually a lot more than just designing the device. Designing the device and building it is by far the smallest part of it. So this kind of research has a unique feature to it, and that is that it turns out that we need to spend energy on regulatory issues. And normally, when I started research, most people in a group would analyze data or collect data or everything. But now, because these devices are not standard available, they don't have CE certification, we need to do extra work to convince our ethics committee that it's safe to use these devices. And that's because companies are not able or not necessarily willing to invest a lot in getting the CE mark or the FDA approval before they know whether it works well enough for the medical field. So we need to prove that it works well enough for them to be able to move forward. And that's where I find myself spending about 1/5 of the research funds on people in my group that only do regulatory issues. They know all about the regulations. They know which tests need to be done, and they spend time basically on things that we would normally ask a company to do, but in this case is on our shoulders. Because if we don't do it, those devices will not get in our hands and we won't be able to do it. And that also means that this stage has to be funded by public funds. If we wait for companies to do it, wait for them to be convinced there is a big enough market, it's not going to happen. We hope that, you know, there will be 1 or 2 devices, competition is always good, that are made in such a way that they will be satisfy our research and patient needs for the next 20 years or so, 10, 20 years. Because it's so much work to get it approved, and once you have a device and it's approved, you're not allowed to change it. So that's the devices we have been working with, which are no longer made now. They're basically 15 years old in design, and they're not going to change. So it needs to be stable, which means that it has to be able to record, but also to stimulate. I'm a firm believer that if you make a device, you need a decent market. Well, that's kind of an open door, of course, but to have a good market, you need to have a device that can do things not just for BCI, but also for other purposes like deep brain stimulation. And so the same device can be used for different types of research. I really believe that's important. So if I look further away, I see very small, very capable devices, minimal surgery that will restore disabilities or loss of movements and communication at a level that will be almost indistinguishable from people who are not disabled.